Afternoon. I'm Lloyd Granville, NetApp CTO for the DoD and Intel Community. With me today is Dan Holmay, our Global Go-to-Market Artificial Intelligence Leader. Today, we'll be sharing information on how we at NetApp are continually evolving technically and strategically to support the DoD's efforts towards joint multi-domain operations. These are the topics we will cover today. Now, during Operation Enduring Freedom, the 10th Mountain Division of the United States Army was deployed to Afghanistan's Jalalabad region. During this rotation, soldiers apprehended a particular insurgent on 4 separate occasions, but were forced to release him on the first 3 occasions. The time to get reliable identification data transmitted from the field, processed in databases located in CONUS-based data centers, and returned to the battlefield edge units was measured in days. This high-value target was able to hide his true identity, return to the battlefield, and continue fighting against and killing coalition forces during that time frame. Since then, our teams of engineers at NetApp have demonstrated an ability to capture an individual's image and move that image to a ruggedized tactical system at the edge running our ONTAP Select. It's our software-defined data center operating system as that defined storage solution. The image was then replicated to the same storage operating system running in the cloud, utilizing our CVO or Cloud Volumes ONTAP, which is the cloud version of our flagship ONTAP data management software, where cloud-based compute resources were then used to execute facial recognition processes against a small 100-image data set, thus resulting probability of a match was returned to the tactical system in less than 1 minute. Now imagine if this capability had been available to the soldiers of 10th Mountain when they were deployed. This use case demonstrates the real power of a well-thought-out data fabric, thus enabling military personnel deployed to remote locations with limited compute assets and disadvantaged communication links to utilize the cloud, AI, ML data analytics located in forward or nationally based resources to achieve an advantage over the common adversary. NetApp's data fabric creates the ability for DoD entities to utilize the data they collect, process, analyze, exploit, and distribute it as valuable information to the endpoints where that information is needed, seamlessly and transparently, and eventually across a joint multi-domain battlefield. Tactical on-premise and now cloud-centric data deployment models are the new normal within DoD organizations. These mixed environments offer hurdles and challenges around data mobility, management, and security. Data mobility and management mean seamlessly connecting these different deployment instances, whether remote, tactical systems on the edge, national and regional data centers at the core, or hybrid cloud environments, into a common data fabric. NetApp's portfolio delivers the promise of the data fabric by bringing data from the edge efficiently to the core data center or hybrid cloud environment, or extending applications and tool sets from the cloud down to the core or edge user to execute his or her task, be it maintenance, personnel management, or multi-domain battlefield operations. One of the DoD's main efforts supporting multi-domain operations is the JADC2 project. We at NetApp are actively supporting and continually pursuing new opportunities within the JADC2 umbrella of projects that span the breadth of the DoD, from the Air Force's ABMS, the Army's Project Convergence, the Navy's Project Overmatch, and as the Space Force establishes its IT enterprise, we remain lockstep with their strategy teams developing solutions. NetApp is not only looking at the data management problem space with ingesting and accessing the differing data formats used by sensors across all the services, but we are also utilizing our internal AI ML team to present a holistic strategy that we feel will benefit the JADC2 program efforts. You'll now hear from my cohort, Dan Holmay, our AI leader in the Globals vertical, who will provide you with further detail on how we're making great strides in innovation by including AI and ML solutions. The floor is yours, Dan.
Thanks, Lloyd. Appreciate you having me here with you today. And one of the things that I just want to touch on, if you go to the next slide, of really all the goodness that is built on the data management and that data movement and mobility that you talked about there, is really the backbone of that leads into how data scientists and these missions can be supported by being able to have access to that data and really bringing the data to the data engineers, data architects, and data scientists to work on it, whether that's on-prem, at the edge, near-prem, or in being able to deliver that back to and from the cloud to really, again, deliver on those mission outcomes that your customers are looking for. And to do that, it's even above a layer above that hardware infrastructure, and really looking at the different things we have from a software layer that really activate that data fabric. And in addition to that, we've added things like the NetApp AI control plane, the data science toolkit, and worked very closely with an extremely well-vetted ecosystem of AI and ML algorithm partners, solution development partners, and our close relationship with NVIDIA and building out a NetApp ONTAP AI integrated solution is really where the value comes, to be able to help improve your models, enable that seamless hybrid AI cloud training and inferencing, get faster ROI from the AI investments, and get to outcome faster, and actually future-proof your investment. So a couple of examples that I want to just talk through that I think will illustrate kind of where we've taken that infrastructure backbone and ONTAP AI and the control plane and really put it into play. If you move to the next example, and this will showcase kind of being able to move data from the edge to the core to actually do that heavy lifting and model training, and then get actual results. The first one here is really looking at using predictive or computer vision for predictive maintenance on structures. We have a ton of infrastructure in this country that is deteriorating, and you look at being able to move and use an unmanned vehicle out to take still photography of the undersides of bridges and actually detect in real time defects there and actually note them. So obviously saving time, but rather than having a human have to go out and physically inspect these things. But being able to move that data from the edge in real time, crunch it against your model, and flag those structures that need to be reviewed by a human can cut down on cost and time considerably. If you move to the next. The next is something that's near and dear to my heart. I live in California, and wildfires are a real thing that we have to have a real concern about during the summer times. This is a real actual use case with CAL FIRE and the U.S. Army of using UAVs in real time to look at anomaly detection of where there is actually fire spreading, and then also where there is danger of that fire spreading, especially as you look at civilian areas or into high value property. So there are algorithms that are out there to actually use satellite, aerial, and drone imagery data to analyze the data in real time and supply back real intelligence to a human that is much faster than sending somebody out into the field and into danger, frankly, to look at these areas and make decisions about where they need to deploy resources. Next. Finally, the last one I think is interesting because it has a dual purpose of either both supply chain optimization and maintenance scheduling. If you look at sensor data or even still photography of looking at wear on moving parts on any number of vehicles, you can actually use classification and defect detection algorithms to look at what parts and pieces need to be maintained, replaced, or repaired in real time without having to have that go-to failure. It also helps from that supply chain factor of where your physical hardware is in the world and where it needs to be. So these are just a couple of examples of how deploying NetApp's backbone of that data fabric and being able to move ingest at the edge to the core, train up your models, and get that inference data back to the edge to give real-time intelligence to humans is where NetApp can play a critical part. I'll throw it back to you, Lloyd. I look forward to talking to you more.
Thanks, Dan. To see our full portfolio of services, you can look us up at www.netapp.com or cloud.netapp.com. Take care and enjoy the rest of the TechNet Augusta conference.